Question 4 and the mark scheme can be bullet pointed into 5 tasks. They are 1. Use of comments, white space and layout to aid readability. 2. Using repetition, such as a while loop. 3. Using a selection statement, such as if, to select between different paths through the code. 4. Validation checks. And finally 5. Input and output. This is the original question from the GCSE 2020 Computer Science Specimen Assessment Material. This question is based on a Parsons problem. Students are required to order lines of code to reproduce a working solution. By using the test data provided, students will know when they have correctly ordered the code. It is important that the lines of code are not changed and that students do not add new lines of code. This is the file that the students are given during the exam. The question provides a high level of scaffolding where the student does not have to write any code from scratch. In summary, the marks for response A were awarded as follows. 0 marks for comments and white space, as none was added. Lines 23 and 24, 1 mark for initial input outside the loop. Line 38, 0 marks for the loop as it is commented out. Lines 31 and 25, 1 mark for the upper bound check on line 31, which occurs after the lower bound check on line 25. 1 mark for the secondary check on line 29, which occurs after the primary check on line 27. Lines 36 to 38, 0 marks for next input as no loop is present and input lines are commented out. Lines 26 and 32, 2 marks for correct error message on range validation. 3 marks for the correct message following each test on lines 26, 28, 30, 32 and 34. 2 marks for correct outputs for primary and secondary input, but 0 generates an error message on line 34 while every input exits, rather than just 0 as an input exiting. The total marks awarded for this response are 10. You or your students may wish to annotate onto this example those accredited points, and then look at how they might improve them to score a higher mark. For response B, marks were awarded as follows. Line 26, 1 mark for at least 1 comment explaining the logic. Line 24, 1 mark for the initial input outside the loop. 0 marks for the while loop as it was not attempted. Line 29 and 27, 1 mark for too big logic, which follows too small logic. 0 marks for year checks as not attempted. 0 marks for next input inside the loop as not attempted. 1 mark for the messages on line 28 and 30, which match the tests on line 27 and 29 respectively. 0 marks for stage messages, matching tests as these were not attempted. And finally 0 marks for outputs, as test data does not produce correct results. The total marks for this response are 4. Again, review the mark explanation document for additional explanation, including how this candidate could have improved their response. You might want to consider how different this response was to the first, and again, how you might improve this response to achieve higher marks. This type of question is based on the concept of a Parsons problem, in which lines of code for a working solution are provided and the students order the lines to produce a functional solution. If you are not familiar with Parsons problems, you can find more information online. They are particularly useful for beginners when they are starting to learn to program. As with other question types, it is best to consider the time constraints first, then develop a working solution to a simple problem. Parsons problems do not need to be complicated. Too many jumbled up lines will make it difficult to pick out the distinct blocks of logic. A variation on the theme may be to present the lines with the correct indentation. This provides scaffolding to help students identify which lines go together to form which blocks. Providing test data and results, students can monitor their own progress towards producing the solution. When allocating marks, be aware that alternative arrangements of the exact same lines may produce a completely functional solution. This is because some blocks may be entirely independent of others, or they do not have to be done in a certain sequence to solve the problem. For example, this can happen with arithmetic, relational, and Boolean operators. This type of question gives students the opportunity to demonstrate skills in analysis, reading and interpreting code, and testing. You can use this flowchart as a step-by-step guide to both support the creation of this question type, but also the decision-making behind creating an accessible and challenging question for your students to complete.